taxometric studies of phosphogypsum as substrate of bioprocesses review. Should be mentioned its topic according my research that I now provide in Prague, and it's according fellowship program Marie Skłodowska career for postdocs. Under this topic, it's very complex this topic, and only some small part I should be presented today, because when we tell about phosphogypsum, it's some type chemical waste. It's not only problem in Ukraine how to do with this type of waste, but in general in the world. And we have some of opportunity for a new way to recycle this type of waste, and also discovering some possibility of biotechnology with this. Some approach you can see on content. And about our sustainable development goals, it's all time we tell about the sustainable development goals and how we can manage a different type of waste, and how we can manage it as a sustainable feedstock. Sustainable feedstock connection with possibility to use different type of waste and get very useful for us products. And mostly it's connection when we tell with possibility to use waste, we can analyze its different sustainable development goals for climate action, for clean energy, responsible consumption and production, and infrastructures innovation also, and mostly land deployment. And chemical waste such as phosphogypsum also can be here together with organic waste. And if you see its connection with bioprocessing, especially, first of all, it should be mentioned about phosphogypsum, because sometimes it's also question, it really can be mineral resources or it's only waste is dumping. Most of all, we can see such chemical reaction and how we get this phosphogypsum from waste phosphate fertilizer production. And mostly we see 5 tons phosphogypsum per ton of products phosphoric acid we get. It's really a lot of phosphogypsum, and you can see photos from Sumy region in Ukraine, from top of platform of phosphogypsum dump. It's mostly around 15 million in Sumy region, only in Sumy region in Ukraine, phosphogypsum. Also, when we go to the world, we see the location of phosphogypsum generation, and it's really amazing. It's a lot. 52 countries have such type deposit of phosphogypsum. And what we can do with this phosphogypsum? Can we analyze it a possibility to recycle it? Yes, it should be mentioned that phosphogypsum can have different type of contamination, and also its connection with raw materials that we use it. If these raw materials have radionuclides, it can be also present in phosphogypsum. But it should be mentioned the technology and raw materials different impact for these resources. And now it's a really big question and big opportunity to recycle such type of waste. Especially it should be mentioned that today bioprocessing involved for different waste recycling. And after monitoring of phosphogypsum dump in Sumy region, we see the different interesting aspect. How can be reclaiming and remediation the dump using this phosphogypsum as substrate for microorganisms and planting, because type of phosphogypsum have also useful components that can be a really good use in agricultural sectors. And we analyzed some of specific microbial species that can be grown in phosphogypsum according to these trends today, and we use in different databases for this. Of course, when we tell about metataxometric approach, we can analyze it first of all by informational electronic databases that provide some of metabolic pathways useful for biological processing and production some byproducts, metabolites of microorganisms. Taxonomic studies that now is also very targeted, because phosphogypsum it can be different processing. We understand that have some classical, how to say, more current use phosphogypsum in construction and building and in agricultural sector as melorants. It can be used. It depends, of course, with contamination, because if phosphogypsum have radionuclide contamination, you cannot use it directly in agriculture. But not all phosphogypsum have this contamination. It depends on raw materials and technology. So meta-analysis also basic approach for integration some hypotheses and to test it. Today, when we mostly checking the opportunity of phosphogypsum, we can analyze it the most specified microorganisms that can be useful in industry and biotechnology industry, and then can be used for utilization this type of chemical waste. For this opportunity, different possibility to analysis you can see in such slide of methodological approach, and also to cut some time, we should to understand how it's involving for this conversion process different group metabolites, production and enzymes technologies. And mostly analysis can be firstly starting to see the components of phosphogypsum that can be really useful and suited for growth different group of bacteria. You can see such map with location of dump in some regions, and we get sampling. Its monitoring mostly provide more than 10 years. We see components is the calcium, sulfur, yes, the basic components, because as mentioned, the hydrocarbon sulfur calcium dioxide is the most important part of this type of composition. But we also have some trace elements. These trace elements can be also useful. Zinc, cuprum, for example, also ferrum. So it's really can be useful, and in microbiological testing, when we discussion with specialists in microbiology, also some of synthetic nutrients that using for bacterial growth will be comparison with the minerals components that presents in phosphogypsum. Especially when we go to thinking about this, we try to analyze it and provide some review of previously research in this field. And of course, it depends of location phosphogypsum. We can analyze the opportunity how to use bacterial groups for how to say provide valorizations of products from phosphogypsum. It's possible to remove some toxic components from phosphogypsum, possible to promotion plant growth and use processing of sulfur oxidation and sulfate reduction. It's also provide of several groups of bacteria. And also a phylogenetics tree representative of some possibility of these groups of bacteria interesting to analysis and estimation. Especially it should be mentioned these groups can be as aerobical condition, species for aerobical condition. Also, we have species for anaerobical condition. So two groups of biotechnological processing without oxygens and with oxygens can be used for such type of phosphogypsum conversion. And it's also interesting. So it can be the largest technologies applied. Especially, by the way, when we tell of phosphogypsum and possibility culturable in microbiome, a lot of species can be useful to biopreparates in agriculture sector with growth plant, because some symbiotic bacteria such type, and it's also very interesting way. So when we tell about biotechnology solution and how we can use dumped phosphogypsum as sustainable technologies, it can be a biology of racist materials, bioreduction of sulfite to sulfates, and mostly the sulfates can be in soluble form, reduction by sulfur, by purification of biogas, and biofertilizer production. Especially when we tell about sulfate reduction and sulfate reduction bacteria, it's also about possibility to utilization different type of organic materials. For example, sewage sludge from wastewater treatment system. I think I need to check time. Okay, it also can be possible to precipitation heavy metals by hydrogen sulfide that we can get from metabolism sulfate reduction bacteria that use components of phosphogypsum. So we can detoxification as a waste and using a natural mechanism by reduction of sulfate and have metals in fixed form. In such pathways you can see on this slide, it should be mentioned that we have some isolation microorganisms in the medium of phosphogypsum, and the combination of this medium you can also see with sewage sludge. Some of processes phosphate oxidation also can be useful. It's also important biofiltration when we get biogas. Biogas, you know, it's mostly methane, CO2, and of course some impurities at hydrogen sulfide can be in biogas. So we can also oxidation and to get such products as sulfur. Especially it's interesting for bacillus growth on phosphogypsum and estimation opportunity in biofiltration. Maybe I don't tell about this opportunity a lot because it takes a lot of time, but it should be mentioned that acidophilic microorganisms very suited for phosphogypsum, and it can be useful for raising elements removal and get, because it's also technologies is now actualization and a lot of discussion. Other type of opportunity is E. coli. It's also in modern biotechnology using as indicators in different test procession. So we have some testing of phosphogypsum substrate with different doses of phosphogypsum for E. coli growth. It also provides some type of effect on growth with comparison control, and in this conclusion it should be mentioned a very important to optimization dosage of phosphogypsum that will be useful for growth bacteria, and also analysis and environmentally friendly solution for detoxification if we have some harmful components, and receive some most basic approach for get good byproducts from phosphogypsum and to see phosphogypsum as sustainable resource. Thank you for your attention, and I hope this research will be continue successfully in together with our partners, and we see the results for applying some biotechnology for phosphogypsum recycling and to get some valorization for useful bioproducts production. Thank you a lot for your attention. It's the first my presentation. If you have a question or something, you can ask me. I will be glad. We have 5 minutes for discussion and
I think it was 3 minutes.
3 minutes, 10 minutes for presentation.
Yes.
And 3 minutes for discussion. If you have question, you can ask me. If you think in, please think, and you can text me. You have my contacts. I will be glad to different opportunity to collaboration. So let's do. Yes.
I have a question. What about the volume of gypsum? What about the volume of fosfogipsum during the war in Ukraine? Is it increased? Have you any statistics?
Most of all, now in Ukraine allocated more than 55 million tons. It's located, it's dumping. New, how to say, fresh phosphogypsum also can be in some regions. For example, if we have one dump, it's closed, and one dump is active. So new phosphogypsum we can get also now, but it depends on regions. And nevertheless, we have a big volume of this phosphogypsum existing, and it's dumping only, dumping without processing of recycling. In some regions, it's good that phosphogypsum have mostly very good quality because we don't have radiation contamination, radiation pollution. So it's also some other problems for phosphogypsum. It depends on generation. So
thank you so much for your contribution. I found it very interesting. Although I'm not a natural scientist, I'm from the Department of Asian Studies. So my question may be not very relevant to this, but do you have some colleagues in Ukraine doing research on phosphogypsum?
yes, of course, because it's a
maybe I would be interested if they are still able to do their job because of the war of Ukraine, how they are affected.
It's a big country, and it depends on regions. Some regions have very effective, it's possible work, how to say, kids should be outside, go to remotely work, and of course it's problematic, but it depends on regions. Some regions we still work, and mostly I go to Ukraine. Yes, I have some visiting trip. According to my investigation, I go to some region, for example, in October. So it depends on regions. Okay, thank you.